So we're coming to the final discussion, the panel discussion that will try to sum up the 2 days of the conference and discuss maybe the most crucial points. You are very much invited to contribute your questions, your remarks to this discussion, if you like. Just give me a quick sign if you're here, and please don't be too decent. Just wave at me if I don't see you immediately, so that none of your arguments will get lost. Okay, let me briefly introduce you to our panel. Most of them you already know, so that we can do that really, really briefly. And I was asked by the technicians not to use this microphone anymore, so that we don't have any interference. Okay. The start, Professor Tanja Schwerdle will join us here, and then we have 4 participants here and 1 connected from the US. Joachim Schutz, welcome to the panel. There he is coming. This morning you already heard Julian Higgins. He is joining us as well, and we have 1 speaker that hasn't had a talk in this conference, but you have heard him already. Please welcome Dieter Schrenk. He is professor and head of the Department of Food Chemistry and Toxicology at the Technical University of Kaiserslautern. A very warm welcome to our panel, to you too. Yes. Okay, and in the United States and California, we are connected to Sander, Greenland as well. A very warm welcome to you, connected to us.
Thanks for having me.
Okay, let's get started. And after 2 days of quite some details, I would like to ask you all for your personal opinion, for your point of view. Do we need epidemiological studies in health risk assessment? And if so, why? Or if not, why not? Just give us your most important argument. Would you start, Tanja Schwerdle?
Happy to. So, well, I'm quite convinced that the best model for humans are humans, and therefore there is no doubt that we have to and should to use more human data and use the evidence from these studies for our risk assessments.
Okay, so that is a clear pro. How about you? Mr. Schütz.
How long do I have for an answer?
Quick answer. The most important argument for you.
Obviously, as an epidemiologist, I would agree, because we are not doing these studies for nothing, and I think we are doing that health risk assessment for complex people who have a complex life.
Excuse me for interrupting. We just heard we are having problems with these microphones, so we do have to use these ones. We have to share.
So as epidemiologist, of course, I support the statement that the epidemiological study should be part of the health risk assessment, which ultimately also leads to the prevention of disease. And we are not doing these epidemiological studies for nothing. We do it because we believe in it, and we think that studying complex people with a complex life is the best to prevent disease in complex people with a complex life. And I think it came clearly out that the main limitations also of this interaction between risk assessors and epidemiologists is probably that both the epidemiological studies and the risk assessment are done by complex people who are living a complex life, because it looks that we have a lot of good tools, and I mean, it's very often the human factors that actually lead to some distortion here. And I think these are problems that can be ironed out. I mean, we heard a lot of examples how we should probably also communicate different types of bias, how we should more honestly use and interpret statistical approaches. That was the last presentation by Professor Greenland. And by this, I think it would be a missed opportunity if we neglect epidemiological studies and health risk assessment. I mean, it would be a failure, I think, of science if we were not able to do so.
Okay, thank you so much. Mr. Higgins.
Well, I give a quick yes, I support the idea. I mean, I struggle a bit. I don't know enough about risk assessment to see the difference between that and epidemiology. For studies in humans, human populations. Clearly, we've just got to use the best evidence that we can, ideally from humans, very well conducted studies interpreted appropriately. But where we don't have that, we need to use other sorts of evidence that might not be epidemiological. So use it if we can, if it's there. Otherwise, use something else.
So I see a tiny little bit of doubt on your face.
No.
Professor Schrenk?
No, there is no doubt.
Okay.
So my answer is clear. I mean, at EFSA, I don't work for EFSA. I'm an EFSA expert, external expert. We are even forced to use human data as far as possible. So there's no doubt for me that we need to take into account epidemiological data when it comes to food safety assessments. The question just for me is, what is the methodology? Because as Professor Greenland has pointed out, there are very tightly controlled experimental studies. So, and these are mostly animal studies, and these studies have contributed to the evolution of a methodology. And this methodology, I think, cannot be applied in a one-to-one exercise to epidemiological data. That is the challenge, I feel. How? Because consumers and risk managers expect us to come up with a number or a quantitative assessment on the safety. How safe is this food item, and what is the level which still can be considered as safe? So a quantitative and numerical outcome. And what is the methodology to come to these numbers based on human data? That's my question.
So we'll address the challenges, but quickly give the word to Professor Sander. Greenland, what would you say? Do we need EPI studies in health risk assessment? And what is the most important argument for or against it?
Well, I think the others have said just about everything I would, and clearly, I think it's crucial
At the
that
moment, is it possible to raise the volume, or do we have any other acoustic problems?
Can you hear me? Can you
Hang
hear me?
On. Can we raise the volume of Professor Sander? Greenland, sorry, I always get. Try to speak again. Try to give us your answer again. Can you hear us? So.
I can hear you fine.
Can hear you as well. Perfect. Go on.
Good. Okay. So yes, I was saying that of course I agree with what everybody said, and they've said most of what I would, but I would add that I think that we would even put the question in that qualitative form of should we use it, is that there are some people that would question to say, oh, we should ignore it, reflects a legal political bias, at least partly, because I've seen it in the United States where it's clearly being questioned because it threatens certain interests. And that's, again, one of the political realities that I've been alluding to. And then even when it's not denied that it should be used in some ways, we get tremendous controversy over exactly how it should be used and what it said. I again talked about some of those sources of bias. Naturally, certain interests are going to prefer using it in ways that refute possible detection of risk, and they want their stakes are to give the null the benefit of the doubt. But then there are plenty of consumer stakes which are much more precautionary, which don't they're threatened by giving the null benefit of the doubt. And in fact, Jerzy Neyman, who was one of the founders of null hypothesis significance testing. Well, he called it a hypothesis testing for any sort of hypothesis. He gave a clear illustration towards the end of his life out of concern for these things, showing that your approach would and should be very different depending on what your stakes are on the null, let's say no effect, versus there being some effect. And he uses a very clear illustration from a chemical risk. So what it really comes down to is how it should be used. My view is that all evidence, all data that we have should be taken into account, regardless of where it comes from. It's just a question of using it cautiously, properly. And then, of course, the integration issues are complex. They can be tackled, and we saw an example of that in the last talk. So that's my answer.
Thank you very much. So I think we all agree that there is high potential of these data and that they should be taken into account, but there are some challenges. And if I got you right, your major challenge is that you say, like, we have to ensure that the conclusions are correct, that we interpret these data correct. Is that, did I get it right? So let's ask for more challenges. Where do you see the major challenges?
Let me just add that we interpret it correctly, and that includes in light of the stakes that are lurking behind this and the motivations. It's uncomfortable, it's unpleasant, and it's reality. We can't avoid it. It's just like in the political world at large. The human factor is huge.
You should see our audience there all nodding. So you have a lot of unhearable applause for that. Thank you so much. I'm still collecting more challenges. Where do you see the biggest challenges for the weeks, months, years to come?
I'd like to probably challenge your statement of we have to get the conclusion right, because sometimes we can get the conclusion right based on the data we have, and it is still the wrong conclusion for the research question that we intended to ask. Because, how we measure exposure, how we do the study is also sometimes a learning process. And we have many examples in epidemiology where the field really improved with generations of studies. So a conclusion is also not necessarily something that is put forever in stone. It can change with new knowledge that becomes available. Sometimes also it changes with just populations and transitions, because we have new combinations of exposure that people are exposed to, and this can also sometimes again change risk profiles that we had that we thought we had understood in the past. So I think we just these dynamics and this, that everything is based also on human factors. We have to somehow respect this also more for the risk assessment. We are not getting a mathematical quotation here where we can just put 1 + 1 is 2. And of course, a robust methodology is what we like. But epidemiology, the life that we are observing will never follow a methodology. We have methodologies to observe the life that people are living, but they are not following an SOP.
Professor Schrenk, you wanted to add something?
Well, yeah. Talking a little bit about methodology, we heard today, and I think yesterday, about methods in epidemiology. It was very interesting for me. Let me say a few words about the methodology. We, as toxicological risk assessors, when it comes to food safety, chemical food safety, I have to say, which we apply. First of all, we define a reference point. A reference point may be a benchmark point, maybe a cancer incidence in an animal experiment. And in animal experiments, this usually is statistically significant. For that reason, we take a clear effect, a clear, strong effect, because you treat the animals with a relatively high dose in that case. We don't do that, but literature does it, shows us, and then we call this a reference point, and from that starting point on relatively safe grounds, I would say, we apply a safety factor. The safety factor may depend on the nature of the compound. Is it a genotoxic carcinogen, yes or no? And we have default factors, and with that, we come either to a health-based guidance value saying that is safe, this dose is safe, or we come, in the case of genotoxic carcinogens, we come to an acceptable margin of exposure. So this methodology cannot be applied just as it is to epidemiological data. Where in an EPI study do you find a 10% cancer incidence in the population? That would be, thanks God, we don't have these numbers. So where is our reference point? It, of course, is lower And what is our safety factor then? Is it also lower? So what is our margin of exposure? No idea. So please help us to discuss this further. It was very interesting today, but I think we need another conference to come to these very practical questions. Sorry for the practical questions, to get your advice in these cases as far as you can go. Thank you.
Okay. Again, if anyone wants to contribute something, has an answer to a question that is arisen here, just give me a sign. And I try to take a look at the chat as well, because we have the lectern in a way.
There are some questions in the chat.
Okay. First, because Professor Schroeter wanted to add something, and then we get back to the chat. Okay.
Well, I learned these 1.5 days a lot. And I learned that maybe the risk assessors, and I'm also a risk assessor with toxicity background, we are asking the wrong questions. We want to keep our approaches. We want to identify the most sensitive study, apply this, and then identify the reference point and so on, and do the risk assessments as we ever did them since we established these risk assessment methodologies. And this does not fit with EPI studies, and it's maybe good like that because our risk assessments and principles are getting more and more complex. And maybe it's a bit of outdated when we are not talking about regulated chemicals to use these type of risk assessments. So maybe we have to come from the other side, not to change the process from our side, but to take all the evidence we have from epidemiology and see how these will adapt when it comes from the other side, how we can use these in risk assessments.
So when you say, I experienced that it doesn't quite fit, did you develop an idea to make it fit better?
Well, I have some ideas, but I feel these ideas should be addressed. I'm not an epidemiologist, so I feel we have to discuss more into deep. For a risk assessor, I feel, personally for me, it's not needed to have all these specific discussions on risk of bias, all these specific causality discussions. I first want to understand what is the evidence I can really need for my questions? How can I combine all the evidence from different EPI studies, these enormous data sets? What can I extract, not to change the study designs, but to change our approaches? But this needs a sophisticated discussion. And maybe we did, as risk assessors, the mistake to ask the wrong questions. That's what I feel at this stage.
Okay, thanks very much. As promised, first the chat, then up there, you're third.
Well, the chat will be new questions, so if you want to comment on the...
Is there a question in the chat? No.
Maybe I can ask Professor Schrenk. I mean, if I understand you correctly, it's almost like we need the grand unifying theory to be able to judge all lines of evidence according to very similar standards, be it animal experiments, epidemiological data, QSAR methods, and this will be a huge challenge because now our understanding is that all these lines of evidence have very specific and very particular, let's say, bias structures and issues, and at least it's a bit difficult to think about an overarching theory or system to impose on all the lines of evidence. So in that regard, perhaps the status quo is that we have to look into the quality assurance, so to speak, line by line, and also keep the science in these lines, but then combine it, of course, at the end into a weight of evidence. Thank you.
So do we need a magic formula?
No, I think I agree with you. There is no world formula in chemical risk assessment. I don't think it will be. I didn't talk about an overarching concept. The idea more or less is a reference point is always, you need a starting point. You need a starting point. The consumer wants to know, is this safe or not? That's the right of the consumer. Is this food item safe or not? Please tell me. This is what BFR is about in the end, for example. overarching approach, I agree with you, is probably not the way to go. I agree that we need an adapted approach. How will this adapted approach for epidemiological data look like? And for the holy grail for toxicologists is the dose-response curve. How do you generate, model a dose-response curve to find where your dose probably causes a risk? And that's something we're struggling with, for example.
We had one more question at the very high.
Yeah, I just wanted to comment on whether risk assessment should change or epidemiology should change. And I think that if we look at risk assessment, it is still a developing field. I think that it is moving to be more adaptation of scientific methods. So as soon as we challenge new problems and we have to face new type of data, then the methodologies for risk assessment should change and adapt to that, to be able to take into account, as it was said also in the panel. And one example of this is the assessments of climate change, because that sort of introduced a completely new type of problems and new data to manage and to handle. And I think that we are seeing the same thing as with the emergence of evidence synthesis and systematic reviews into risk assessment. It is also introducing changes. And maybe it's a moment to actually change some of the risk assessment concepts that's been around, like the use of safety factors. It's really, really difficult to combine that with very thorough investigation of evidence and evaluating risk of biases, and then suddenly you add an uncertainty factor onto it to take into account sources of uncertainty. So I would rather question the use of safety factors.
Okay, thank you so much. Mr. Higgins, I wanted to ask you about your major challenges. What do you see coming up? What is the thing that we have to overcome in the next time?
Well, I don't work in risk assessment, clearly, so I can't comment on that. But one thing I do observe from this conference is the plethora of tools that are being developed, which I think if we want, international understanding of the effects of these exposures, we would like to judge things in the same way wherever we do it. And I'm not going to argue for our tool to be the favored one, but it would be good if there were fewer tools and more consensus on how to approach the evaluation of an understanding of whether we should believe an estimate of an effect of an exposure on outcome.
Thank you very much. I saw a laughter in the US. Do you agree, Professor Greenland?
Well, I thought it was strange the comment that fewer tools. I want, and any technician in any whether working on cars or rockets or TVs, wants more tools. They build specialized tools. The bigger our toolkit, the more options we have to do the job quickly, efficiently, and correctly, get it fixed. So I mean, I presume you had something else in mind that I misunderstood there, perhaps, in saying fewer tools. There are, I would interject that there, for example, there is this AI portion of the literature that has influenced epidemiology a bit. The causal diagrams, they're largely, that whole causal diagram theory that's now big in epidemiology, largely came out of AI research in the 1980s. And the same people are working, trying to build systems that can do good jobs with causal assessment. And part of the areas that they're working on is evidence synthesis from different lines of evidence and developing models for that. And the conference here looked very interesting, but I didn't see any mention of that. And my impression of that literature is that it's sort of not ready for prime time. It's very much focused right now, or so formal that it will really only apply in these AI systems or maybe robotic systems and immediate problems. But still, they think, and it holds out some promise to become an important part of our toolkit if we're doing risk assessment. And since I've got the microphone, as it were, at the moment, I would also like to add from earlier things I've heard, part of working out a good solution to a problem is to frame the questions well. And one point I've emphasized a lot is that we need to get away from dichotomous thinking. It's human nature to be black, white, safe, unsafe. There was a statement, and it's true, that the public wants to know, is this product safe? The problem is that the public, it would be better if the public and everybody was educated to understand there's levels of safety, what's acceptable risk and trade-off. Like cadmium, we know it's a risk factor. A ideal diet environment wouldn't have any of it in there, but we can't do that. So we have to set levels where there's some acceptable risk, given the trade-offs. The costs of trying to get to zero could be far too great, could bankrupt an economy. So that it's better to encourage that kind of thinking of that. It's not dichotomies. It's what we have to address that continuum before we can start talking about standards. That's my view.
Okay, thank you very much. Because you wanted to answer.
I mean, actually, my take home from this 1.5-day conference, which was extremely useful, so really thanks to BFR and EFSA, is that I even understand less where the problem is. I mean, maybe there's only a communication problem, but I mean, at the end of the day, we have the same goal. I mean, yes, I hear from you, we want to know, is a product safe or not? And you say you want to understand the dose-response relationship so you can make this assessment. So now I'm coming from cancer epidemiology. Our aim is to prevent cancer, but ultimately we need to understand what is the dose-response relationship between different types of cancer and the different exposures that we are looking at and that we think we have to regulate to prevent for people to reduce their cancer risk. And we heard air pollution as a very good example today. And I mean, the different substances, because air pollution is not one thing. Air pollution is a mix of different agents. All these different agents have a different impact on different organs, and this is why we have different organ-specific cancers with different risks depending on the level of exposure. And I mean, the main difference to the experiment is that we cannot address everything in one EPI study, because if you're doing this study in the north of Sweden, you find different doses of air pollution than when you do this study in the middle of Beijing. And at the same time, a different, where you also inhale a lot of harmful agents. We have a record low smoking rate now in Sweden, and we have 80% smoking in Beijing. These are all realities, but so I mean, the epidemiology is probably more that you always collect pieces of a puzzle. But at the end of the day, putting these pieces of the puzzles together is exactly the same aim that you have in the toxicology studies.
But still, because Ms. Higgins said, like, I would like to have less tools, but more efficient tools, if I got it right.
I was just saying, I don't see it's necessarily helpful to have multiple tools that do exactly the same thing. They do it in different ways and reach different conclusions. So that one group will say, here's the effect of an exposure and outcome, but it suffers from these potential biases. Another group will have exactly the same result and say it suffers from a different set of biases because they use different tools that cover different biases. That, to me, is not ideal.
So, since it was in your talk, Professor Greenland, as well, that you said we have no universally accepted methods, guidelines, or rules, do we need those? That is the question. Do we need standardized procedures to use information from EPI studies for risk assessment? Professor Schwedle and Professor Schwenk.
Well, we need at least transparent tools that we can explain that we all, when we are doing the risk assessments, come to the same results. That's the issues behind the risk assessments. So they are scientifically based, but we have to communicate to the outside world how we come to the result. So we cannot be too creative and innovative from risk assessment to risk assessment. So there should be a guidance behind how we use the evidence from human data.
Well, first of all, I think it's very important that we keep on to discuss this. And EFSA is doing it. We need to bring together epidemiologists and toxicologists to come, and other colleagues from other disciplines to kind of discuss these problems. And this starts already with the definition of the terms. For example, this morning, Holger Schönemann talked about thresholds. And I asked him, what do you mean? He said, a threshold is something we define, that's an acceptable level. And for us, as toxicologists, for non-cancer, we believe in an intrinsic threshold. That means a handful of molecules doesn't do any harm. There is a dose which doesn't do anything. That's the idea. And most toxicologists think this is true. Not for cancer, there is another discussion. No threshold, in quotation marks. We don't know. Uncertainty factors, I mean, if you want to get rid of uncertainty factors, you need to tell us how to replace them, because we need to, I wouldn't say guarantee, but make sure that there's safety, yeah? And that is something I'm afraid that many epidemiologists haven't on their mind and on their screen. You see, your questions are different. So we need to come at first of all to a consensus on asking the right questions, and then talk on the tools. The tools could be flexible, but we need to discuss it in detail. Thank you.
Okay, we have one more question.
Yeah, well, so a more comment. I agree with Professor Greenland. We will never get a black and white answer, and epidemiology is more messy than perhaps animal studies, or the animal studies, because there are a lot of things you can't control, and life is complex. And whatever you do, you're never going to get it down to a simple answer. Perhaps we need to agree, we need to accept this, communicate it to the public. And what we can do is we can have guidelines and tools which make it transparent what we are discussing. And we have to go with this uncertainty and the doubts to the public, and we can discuss our differences. And then it comes down at the very end to a kind of expert judgment when we can't control everything.
Okay, thanks for that comment. We have questions and comments from the users on the internet.
Thank you. Yes. So basically, on the same note, there's a question about combining evidence from different sources, and there is a question whether you consider evidence from animal studies as a always pre-requirement for causality.
Is anybody there who would like to comment on this or answer on this?
Sorry. Could you repeat it? Evidence from animal studies?
Yes. Do you consider that as always a pre-requirement for causality?
No, not at all. I mean, causality is something we heard and discussed about this morning. I mean, who would deny the causality between air pollution and lung disease? There is causality. You wouldn't need an animal experiment, and I think there are animal species which are inadequate models for such causality research. So here, the situation from the human observations is sufficient, absolutely sufficient. And there may be other cases like that, and are, of course. So a clear answer: no, you don't need animal experiments automatically for causality. But of course, there may be cases. Let's talk about cancer, genotoxic carcinogen. Would a compound cause cancer in humans as a genotoxic carcinogen and not in any of the experimental animal species? That is, I would say, quite unlikely. If you have a case, tell me. Huh?
Do we have any more questions or comments online?
We have one more question from the talk from Dr. Greenland, and it's mostly based on the solution. So whether you think the Bayesian statistics could or would overcome the p-value and null issue. So if we clearly avoid any use of Bayes factors that mimic p-values and dichotomic interpretations, would that not lead to rich and nuanced interpretations?
Did you get that? No.
Yeah, absolutely. I've argued this extensively with colleagues who are Bayesians, and quite repeatedly. And I have spent, in a course of 20 years, giving a workshop nominally on Bayesian methodology and philosophy around the world, including in Europe. To me, all these statistical philosophies, they're tools. They're toolkits that are promoted as philosophies. What their differences are in the assumptions, and there are ways in which they map into each other. And it can help to do things different ways if you have a very clear understanding of the differences in the assumptions, the whole setup that each is making. But what I've seen of Bayesian testing methods, and I mentioned that in my slides, I think I covered one of those slides, that Bayesian tests, they were in fact, for the most part, constructed to mimic the very frequentist tests, significance tests that caused all the troubles I was talking about in the first place. So they were designed to cause trouble, if you want to look at it that way, and they do. I've seen the same thing happening. So they're not a cure; they're just a competing brand, I would say, with the same kind, like a competing drug, but with the same kind of side effects. Whether you're talking about SSRIs or NSAIDs or so forth, that's how I view them. They're useful, but not something to be taken as a savior.
Okay, thank you so much. I would love to come back to something that you just said, Professor Frank. You said, like, we need to bring together the epidemiologists and the toxicologists and other disciplines. Which other disciplines are you missing? Who needs to be at this table next time?
Well, I think exposure experts, analytical experts, and exposure experts. That's, I would say, a special group of people we have in the panels. We mainly have epidemiologists, toxicologists, and experts in exposure. Okay. Is that correct, Tanya? Did I forget any discipline?
No, but you said in your introductory talk that you said, like, how can we improve collaboration? What would be the answer to this question?
Well, maybe at this stage it's not only to improve collaboration because collaboration works, but maybe we have to train toxicologists in epidemiology. So, because the issue is that a lot of risk assessors have a toxicology background. That's okay, and that's historically. But for the questions that will pop up in the future, risk-benefit assessments, nutritional behaviors, dietary habits, and things like that, we know we need more disciplines. And maybe toxicologists, which are at this stage the ones giving where the most risk assessors come from, should know more about epidemiology. So it's not that I feel they can learn to be epidemiologists, but to have a broader understanding so that people can work and talk together and establish common approaches.
So what would be a good opportunity or a good frame to do so? Is it something that has to start at university, or is it something that has to come later?
Well, definitely at a very early stage, because if you run in one wrong direction, it's hard to change at later life. So I would say at the very beginning. So there's the idea also from EFSA to establish a European master for risk assessment, and definitely it should be a lot of epidemiology in there, I assume. And we should also put this in other programs as early as possible, because if you are fully trained toxicologist after your PhD, you have a certain idea of thinking. And this will be put on the risk assessment strategies. And so I think we should be more open-minded to integrate these ideas, because we cannot, what I learned, we cannot change the study designs, and it's good like that, because it's different ideas behind epidemiological studies. But so we also have to use the evidence in a different kind of manner to come to a quantitative risk assessment at the very end.
Thank you so much. Do we have any more questions or comments? Yes, please. Do you have a microphone available? Can someone pass the microphone to the front, please? Ja, it's coming. Ja, selbstverständlich. Keep the button pressed, please, so that we can hear you.
Okay.
Yeah, perfect.
Thank you so much. My name is Mariam Genji. I'm studying epidemiology in Charité, and I'm an intern in BFR. I'm very glad. It is my first time coming here, but 2 days I was just observed everything, and now I want to talk about something. I think that there is a gap between the epidemiologists and risk assessment expertise. And I think that it is a meta-research. Before finding a connection between the epidemiologists, before talking with them, you should screen your publications. And it is very important because some of the articles are not completely trustable. You cannot use them. Before that, you should consider some of the methodological and statistical concepts. Be sure about them, and then you can bring them in your cycle for assessment. Without this, you cannot do this. You know, we should do something. We should have a gathering for comprehension. We should comprehend each other. You know, it is not the place for fighting. We would like to find a solution for our comprehension. So it's better to have a solution before finding an epidemiology concepts for solve the problems, and that is the meta-research, in my view. And I thought that finding a descriptive design with a great and very powerful backbone is very important. Without this, we cannot do anything. It is very important, and my background related to biostatistics, and in my view, without any correct statistical analysis, we cannot do anything for risk assessment. How can we do it when you don't have any a strong background in some of the articles? Sorry, but they are junk. But it is, but it is in your cycle for assessment. We cannot deny it. It is undeniable. Thank you so much.
Okay, thank you very much. Does everybody agree, or is there some disagreement on the podium?
If I may, I think you're very right, and that's not a problem, of course, of just one discipline, but of all disciplines. The CEO of EFSA, Bernhard Ull, said, you, at the first place, don't believe anything. You have to scrutinize everything. And that's our job. And to be honest, when it comes to epi studies, I rely on my colleagues, experts, when it comes to risk of bias and things like that. So that's what we do.
Let me check for any more questions or comments. Yes, one more.
My name is Claudia Drossard. I work at the Federal Institute for Occupational Safety and Health. And I'm an epidemiologist, but I work in the toxicology field, so I feel you are representing my life, my daily struggles. But I wanted to comment to Dr. Schwenk, because you said that there is no possibility to derive a POD from epidemiological data. And I think it's a common approach to do so, because you have other measures, of course. In epidemiology, you often have relative risks, and in toxicology, you use absolute risks. But you can, of course, transform the relative risk into an absolute risk if you use the background incidence. So these approaches are already there. And to extrapolate from the point of departure from a toxicological study and from an epidemiological study is, of course, different, because you have to consider different steps. But I think you can't really say which of the assessments is more certain than the other, because in the experiment you have the strong design, but of course you're in the wrong species. but on the other hand, in epidemiological data, you have the right species, but perhaps you have concerns about bias and so on. And so you said you use certain safety factors or uncertainty factors. This is another point I wanted to comment on because we don't like this, this term. We are using extrapolation factors as a term if the factors are empirically based. And this is an approach that you use really extrapolation factors as a default, which are derived from distributions of factors you have in studies that were conducted in a lot of substances. So I think there is a lot of knowledge, and also there are approaches to do it, and perhaps it is important to more exchange between toxicologists and epidemiologists. I do this because I'm in a toxicology group and I'm also in the committees. But I think
talk to yourself every evening.
Yes, yes. But and I want to I think Dr. Schwertle is right that she said toxicologists have to be trained more in epidemiology because traditionally they have this experimental design which is just strong, but the observational studies are really difficult to understand or to understand what is bias and why are all. When I started in my job, the first thing I got to hear was, oh, epidemiologists, they destroy their own studies. They are just telling what is bad about their own studies. So what is really absurd to do so. And so I think it's easier for epidemiologists to understand toxicology because you just can think of an RCT, an animal experiment, but the other way around, it's maybe harder because they are not so much trained in the statistics.
Thank you very much, but I hear the call for more exchange between the disciplines, and you're not the first one who mentioned that, so I think that is something we can agree on and say, like, we will go on. Just very, very brief, because we're running out of time.
Yeah, I mean, what is important to understand is, I mean, we always mention the randomization is the big difference between the epidemiological experimental studies, but I mean, there's many more factors that are beyond our control. And I mean, also with the exposure to start with, I mean, the most exposures we look at epidemiology, you don't have really zero exposed in human populations. You always have some background population. So you don't get this experimental setting where you can really manage to get a zero exposed in the animals, but still we call them non-exposed in our epidemiological studies. But in the main, we mean a reference group by it. I mean, when we talk, for instance, about occupational exposure to asbestos, but that means our reference group of those not occupational exposed to asbestos, they may have environmental exposure to asbestos. So it's not people free of any asbestos exposure in their life. And I can't come up with any chemical or whatever exposure in the environment. Even smoking, I mean, a never smoker had exposure to second-hand smoke or third-hand smoke. So we don't have this zero exposure in the epidemiological study. That's another difference. And we also don't have people who are only exposed to one factor. It's always a cocktail of exposures, which makes confounding, of course, another issue than in controlled settings. And I mean, this is not something we can overcome with new methods or new standards or new languages. It's just a reality I think we have to accept.
So there are a couple of points that need to be addressed still further. I get it. But since we have come to the end of this conference, I might take the opportunity to thank you all for taking the time and joining us.